sort of my view from the research community in the IRS for using AI. And I'll call out 3 areas. There are a number, but I want to just focus on 3 for now. One is in ID theft. This is a profoundly difficult and pernicious problem. It is a human problem. You see it across industries. The IRS is not unique. It destroys families. It is a psychological and emotionally debilitating issue for the IRS. We see this every year, every tax season. The stories are heartbreaking. They are gut-wrenching. Families that are going through their own personal challenges that in some cases involve loss of family lives or whatever it is. During the course of that, they get their ID stolen. They have to work through processes in the IRS that are there for them to verify, identify, resolve, but that are manual, that are human intensive, and that can benefit greatly from the use of AI and data science, frankly, to make those processes easier for households or victims of ID theft to get through and move on in their lives.
Let me ask this, Jeff, because I really want to get to another question that really gets to the heart of why we're here. You know, at Intel, I'm personally involved in 3 major areas. In health and life sciences, where I'm working on immunotherapy and matching pharmacological resources to genotypes and phenotypes. We're working in cyber intelligence to move from cyber defense into cyber threat intelligence as a weapon. And so the question that I have, is what are the real world examples? Michelle, what kind of real world examples do we have where government is actually driving artificial intelligence?
Well, I think one of the areas that I'm most excited about is the application of AI to the procurement process. GSA has 2 proof of concepts that they have developed. My colleagues at the Office of Government-Wide Policy have a proof of concept that downloads solicitations from FBO and evaluates that through natural language processing to see if it has compliant 508 language included in the solicitation. It's a very exciting application of that technology. The other proof of concept that GSA has is the one that's in the IT category. For Schedule 70, it's largely a blockchain solution, but there is an artificial intelligence capability associated with that proof of concept. And that proof of concept actually automates the proposal review process. And I believe that it potentially could significantly reduce the procurement lead time for the federal government.
That's exciting. That's very exciting. We appreciate you sharing that. Now, Jeff Alstad, you and I, we're both in research. So part of our job is to anticipate new and exciting technologies before they actually become mainstream. How do you do that?
Yeah, it's hard. I'm open to ideas from the audience on this one, by the way. For those that don't know, IARPA is about 10 years old, and you've probably heard of DARPA, which is many decades old and brought us things like GPS and the internet, IARPA has a similar model of we acquire research. We run programs where we hire research performers from industry, from academia, and so on, to do fairly large-scale research projects. And so we've had research projects on trying to forecast the future of science and technology. That's one of my focuses. So we're collecting historical data on how technology has evolved over time so that we can have better statements of how technology is likely to evolve into the future, and that includes AI. But you can bring AI to bear on this problem, right? So you can use traditional machine learning techniques on previous data in order to try to make forecasts. In fact, we had a program relating to that called FUSE, which wrapped up about a year ago. And that technology has some utility inside government, but IARPA has no problem with the technology going outside to the public. So that technology from the FUSE program was licensed to a startup, and then the startup was bought by the Chan Zuckerberg Foundation, and so that was a pretty successful win for, I think, society, not just the intelligence community. So we are interested in figuring out what will happen with AI 5 years from now or 10 years from now, so that we can be better coordinated on where all parts of government or industry ought to be in order to take advantage of these things before they're right in front of our face. But one of the ways that you can do that is just make the future technology, right? So if you're researchers
don't
like
steal
us,
Intel's tagline,
right?
because that is our tagline.
So it's a good strategy, I think.
It is.
Possibly a reason why Intel has been successful. So we have been using AI in many different fields, things like detecting chemical or biological threats. We had people doing geospatial stuff talking earlier today. So we've had a public contest of releasing a bunch of overhead satellite imagery of different buildings, and the question is, can you categorize what this building is for, right? And so then that's just an open contest to anyone in the world. It's not classified, nothing like that. And so we invite people to participate in those sorts of competitions, because this is a way that we can develop that future capabilities that use AI. But we also do work trying to make AI better. So I used to be a neuroscientist, amongst other things, and we have a neuroscience-related program that is doing very detailed brain mapping in order to understand really at fine-grained level how the brain is wired up, for the purpose of learning things from the brain to make our machine learning techniques better. Right? And so this is still a program that's midway through, maybe only actually 25% of the way through. But the point is that we can start to imagine what the future of AI a few years or decade down the road might look like, because we're helping to build it.
Yep. Well, I think that's a great strategy, and we're happy to support that too. But you did mention some very interesting things about acquisition and procurement. I really think that this idea of contest and challenges is central to this thought. But Michelle, can you give us a bit more insight? I know you are really an expert in acquisition and procurement. What kind of areas are the government using for acquiring and procuring artificial intelligence and data science solutions?
There's quite a lot of activity in the contest area. Challenge.gov was set up in 2010 by GSA to specifically encourage that particular behavior in government acquisitions. You also have NTIS, the joint venture program there, where agencies and industry are collaborating to develop requirements. There's also more traditional procurement approaches. There's been, our particular proof of concepts have been more traditional approaches that utilized a statement of objectives, where we really didn't define any of the technical solutions. We allowed our industry partners who are experts in the field to do so.
Okay, yeah, I think that's great. I mean, I lead our joint venture partnership with NTIS. We are approved joint venture partner. We're excited about the new business model that it represents. They've led a number of contracts that have been awarded in less than 90 days. So it's a fantastic way to accelerate the adoption of artificial intelligence. And so we really appreciate your work in this area. Now, Jeff Butler, you and I share a very important passion. Now, key to this development and being able to get the benefit of artificial intelligence is the ability to get people who actually know how to become or are data scientists. I've heard that the Department of Labor is estimating somewhere around 2.5, 2.7 million job openings in this country around data science. And so if we don't start growing data scientists and people who are able to gain insight from data, we will never realize the benefit of this set of technologies we call data science and artificial intelligence. How should we approach this problem? What should we do about it?
That's a great question. It's a strategic question.
And take as much time as you need.
Less than 3 hours. This is a strategic imperative, really. How to develop next generation talent pools, take advantage of data science. Actually, so movements, paradigm shifts, right, resurgence, we talk about big data, data science, and AI. These are all related. They go to strategies that agencies in particular need to develop, if they're not already, to ensure that they've got the capabilities to deploy some of these wonderful things that are being talked about here in the coming years. So how do we go about doing this? First step is really awareness at the leadership level that paradigms are changing, paradigms for computing, paradigms for standards of software, paradigms that deal with the skills that are needed to ensure that we've got capabilities to drive innovation through data-driven decision-making into the future. So awareness is one. Boot camps for leadership, boot camps for management cadre. If there's one thing that I hear from staff a lot is my new manager, my existing manager isn't really tuned in to these changes, these profound changes that are taking place, and I feel like I'm on an island somewhere. I want to get moving. I want to explore in these areas. So I think boot camps is a good place to start. Emphasis on interdisciplinary skills. So universities, I was on a panel years ago with Michael Rappa from NC State who created the first master's data science program. He was lamenting the fact that universities really were slow to respond to the need for interdisciplinary skills, that curricula are still largely monolithic, and there's not enough cross-fertilization. Data science programs are a great way to, in effect, force that kind of interdisciplinary attention. I think more of that in the federal space is needed as well. Part of that is how to create a data science series. OPM is slow off the blocks on this one. Most agencies, including the IRS, I just worked over the last 6 or 8 months with a counterpart of mine in the IT organization to use the GS, for those of you familiar, 854 series to create a data science PD, or a set of data science position descriptions for agencies. So some agencies are not there yet. I think we need to get moving there for recruitment. A couple more things real quick. One is agency-university partnerships. How they exist, but how to intensify that for data science AI through internships, other pathway programs. I think we need creative minds to come together and innovate a little bit more in that space. The public-private partnerships are there. The federally funded research development corporations like MITRE, they're there. I think that those are working pretty well. One area that I have talked about over the years is how to leverage National Science Foundation, National Academies of Science, to work more closely with either OPM or agencies, a consortium of agencies, to build a kind of data science academy, maybe an AI academy, where you can formalize a gateway for training at the federal agency level around these programs, with the benefit of standards that come from those partners.
No, I certainly agree with all of those comments. I mean, I'm a member of the National Academy of Science, and we're actively participating in the development of research so that we can engage universities better. NSF has funded the hubs around big data, and they are really focused on trying to ensure all universities and industry and government partnerships really create deliverables that the government can consume readily. So I think these are great things. Now, as a practitioner, we're starting to see that there's a robustness and a fragility to data science and artificial intelligence solutions. So, Jeff, I'll start. How are we dealing with this fragility and robustness issue around the kinds of solutions that are being created?
Right. So this is a thing that our keynote speaker alluded to several times, which is that we're reaching an era in which machine learning techniques can do fantastic things when they are trained with large amounts of data, typically large amounts of data, to do things that we would have never been able to describe how to do it by writing down an equation or explicitly delineating what a stapler is, right? However, if you then take that same machine learning solution and you ask it to operate in some environment that is different from what it was trained on, it doesn't work so well, right? And the differences can be very small from a human perspective. So for example, AlphaGo, which has beat the top players of Go in the world now, if you increase the size of the Go board, AlphaGo doesn't do very well. And that's because it was trained on a Go board of a particular size. if you increase the size of the Go board, human players don't care, right? Because the fundamental dynamics of Go, which the human implicitly understands, don't depend upon the size of the Go board. So similarly, if you have things involving a image recognition or image classification software, AI solution. So it'll be trained on some boatload of data, and we've heard about different data sets that let you do this, to correctly classify staplers and turtles and whatnot. But it turns out, and this is an area of active research over the past couple years, that for some deployed machine learning solutions, you can, if you try to, make images that look exactly like what a human would call a stapler or a turtle, but the AI system will classify it as a school bus or as the Empire State Building or something like this, even though the human clearly says that's a stapler. It looks exactly like a stapler. So the point is that these systems can be rather fragile, and exploring where the space of robustness is versus the surrounding space of fragility is an area of active research. And for most applications, or at least controlled applications, this isn't going to matter. But it's an area that IARPA and DARPA are concerned about. So DARPA has a program called Assured Autonomy that's trying to develop methods to build machine learning systems that are more robust, or that they know where they are robust as opposed to where they are fragile. And IARPA recently had a request for information about building a national test bed for people to test out their machine learning solutions in order to test whether they're robust to different sorts of adversarial attacks or things like this. So if this is just your phone recognizing your voice, it may not be a huge problem if it miscategorizes 1 out of every 10 sentences. But if this is some critical infrastructure,
Like autonomous driving.
yeah, you want that failure rate to be rather low. And even if it is 5 nines of safety, if that last portion of probability, that one time it really causes a big problem, then it's actually a big concern. So again, this is an area that I and others at IARPA and at DARPA are particularly concerned about, but it's an area of active research. But for you as industry members who are practitioners, I just implore you to stay aware of this and figure out ways that organizationally you can have fail-safe modes, particularly have your humans in the loop who understand that the machine is not necessarily always right, and try to develop systems where they are allowed to override a machine when they think that no, it's doing something wrong here. We're not ready to hand everything over to machines quite yet, and so this is an area that requires more work.
Yeah, definitely. I mean, we're seeing it as well. You know, this discussion around narrow AI versus general AI. You know, in our partnerships with BMW and Toyota, we've built out an actual track. We're actually running autonomous vehicles, and we are certainly seeing the fragility of the AI systems and are trying to build in ways that can actually make the solutions better. These are part of the ethical, societal, and legal implications of AI. We won't get into a deep discussion here, but certainly they are top of mind for practitioners and also research scientists like Jeff and I and the rest of our panel. And so when we think about all of these issues, including bias that can be measured or not measured in AI systems, these are the kinds of research environments where we're really trying to get a sense of what can be robust and great versus what is fragile, rigid, and difficult. So I'm going to ask each of you one last question, and then I'm going to open it up to the audience. And the question is, what are the top 2 things you want this audience of government and industry to think about when they think about trying to create and understand the implications of AI adoption? And Jeff Butler, I'll start with you.
I think
Just 2 things.
Just 2 things. First is
Part A. I'm just joking with Jeff. Jeff is a good friend.
First is I think back to awareness in agencies. What are the strategies that are in place today? What are the strategies that need to change? And what is the process for making the change to strategies that are needed at all levels of agencies? Two is, I'll go back to workforce skills as a related but separate strategy. This is a strategic imperative. We have partnerships at agencies. We can outsource. They are there, but we also need, through the development of effective humans in the loop, human-machine interfaces, the domain expertise that can work with the virtual machines as they become more prevalent in our organizations. And that is going to require a change, in some cases a profound change in the way that not only we deploy skills, but think about how to deploy skills, maybe even how to acquire before we deploy. So these are deceptively important challenges that are ongoing in organizations. Sometimes in agencies, for those of you who are in government, like the IRS, such a big organization with so many challenges, but opportunities that go with it, we tend to be reacting more than thinking about these longer-term strategies. Not that we're not thinking about them, it's just that they're becoming more important for us and other agencies as well.
Michelle?
I think one of the biggest concerns a lot of people have when you're implying AI, and it has been definitely discussed by our
Dr. Castellani.
and a few of the panelists here, but for the acquisition process, incorporating AI will not replace the human aspect. It will just assist it. It will assist the increasing volume of work the government is performing with less and less actual people to support that workload.
So can I just stop you right there? So I'm going to make sure I understand that, because that's a very important point that we haven't talked a little bit about. So that sounds like as government data grows and government missions grow, we're expecting that there's going to be a need to understand more of the acquisition policies and strategies that will help the government deal with this larger set of data, larger mission space with fewer people.
Yes, and also a larger workload associated with our contracting officers to be able to manage more with less. And I think that's our current administration is really focusing on doing that as a mission critical function.
Okay.
The other thing that I would like as a takeaway is that it's closer than you think. This is something that we have legitimate proof of concepts to prove the technology works in this particular space, and I expect that it will be something that will be actually implemented fairly soon.
Yeah, that's something I think why these people are all here, right? Because it is definitely closer than we think. I think that what Justin, our keynote speaker, and us panelists are reinforcing is that use cases are abound in government, and that adoption of AI is not Star Trek, it's now, right? Okay, Jeff, I'll start. What are the two things we want to take away from this?
Well, the first one is that and I suspect everyone on the panel, wants to take away things from all of you, right? So, as I said, at IARPA, we're a research organization, but the majority of the work that we sponsor is work where someone came in the door and said, I have this idea about some research topic X that we think someone can deliver, or maybe I can deliver, or whatnot. And so all of you have a lot of ideas, either with research or with applications that we don't know about yet, and we're definitely keen to listen. So please don't just be thinking about, all right, what are these government folks, what do they think the world is going to look like? we could use some crowdsourced wisdom here.
So number one, engage.
Yes,
Engage
please.
the AI
Right.
politic. Okay.
And the second one is just to return to a theme that I made mention about earlier, which is about concerns about the robustness of the systems that get deployed. And just try to have forethought about how could this fail and what will we do if or when it fails. It's just, there's lots of opportunity to have just a little bit of forethought to make things much more safe or stable, which cashes out in dollars and lives.
Excellent, excellent. Well, we've saved about 15 minutes or so for your questions. I want to make sure you get an opportunity to engage these experts in government. So questions, please. Yes, ma'am.
Good morning, Vern Wendt from National Defense University. This question's for Michelle. You talk about proof of concept. I'm just talking, have you thought about the larger scheme of things like scale and scope? Because as we know in the acquisition community, especially Department of Defense, it's like, well, we got it, the GSA is doing it this way, but we got our own way of doing things. So I'm trying to think about, have you thought about the idea of scale and scope and how can that happen?
Yes, the proposal evaluation proof of concept that we have is extremely scalable, and it can be configured to match any requirement that you have, any specific agency supplement to the FAR, any internal policy. You can configure it any way you want. I don't think scalability is really an issue per se, but getting support funding, I think, is much more of a difficult hurdle for us to overcome.
Thank you. Next question. Yes, sir.
The problem with agency culture is this could turn into the shiny new toy. The trouble is that this could be the Tinker Toy vanity project for some SES or political appointee to latch onto. And your problem, and the question is, how do you institutionalize the benefits and get it out of the sandbox?
Do you want to direct that to any one person, or you want the whole panel to talk about that?
What I mean, I can see this happening in other IT ways of IT improvement. This is very significant stuff. This is very, very fundamental. But I can easily see that you have the agency champion will take this on and build a brand around it and all that sort of stuff. But then the trouble is that when it comes to scaling it up into actual production and getting something out of the sandbox, they don't want to do it. And there's even some real problem, information flows within the agencies, within the departments and things like that. And I guess what I'm getting at is, how do you institutionalize the benefits of what you're talking about in such a way that it survives the transience of the management at the top that may take this on and then leave, and then it's without any support at all. And again, your problem is to explain the benefits, and yet also explain some of the downsides in such a way that you will have a way to permanently build this into the agency operations.
So that to me does not sound like an AI-specific problem.
It isn't. Oh, it isn't.
Nor even a government-specific problem, right? It's a bureaucracy-specific problem.
It's a cultural problem.
Right.
And the things I've seen this happen with other ways of improvements and all that sort of stuff, and it's just that, again, and my biggest concern is that as a result of that, the government will fall further and further behind the corporate world. That's all I'm going to say. Thank you.
So I do know that Justin, who's there in the back looking at the food, okay, good. So this is of particular top of mind for him about demonstrating the places where this has been deployed, and is operational within the government, or places where we are just one step away, right? So as to illustrate or where we are or where we can be rather easily. So I am totally on board with the notion that it's a administrative process that requires a lot of persistent effort. But again, it's not an AI specific problem. I don't think it's even a 21st century specific problem.
I'll follow up real quickly. But one, it's a great question. It's a challenge area, right, for many agencies. There's a double-edged sword. You have watchdogs like GAO, Congress, and the IRS. We have our IG, TIGTA, right, that say, as somebody mentioned, we need cost-effective, transparent, accountable service. What are you doing about that? And so the response should be, in my humble opinion, that we're looking to leverage and intensify our use of these techniques, tools, technologies that are available to reshape the landscape of how we address those problems. The other side of the sword is, well, you're doing such a good job, and those of you who are in agencies will appreciate this. You're doing such a good job. Why should we give you any more money? And this is the area that we need to demystify. We need to behave more like corporate cultures that look at return calculus, return on investment, return on resources calculus to the extent that we can, even if it's qualitative, and say we're leveraging and infusing and incorporating these new tools and technologies to improve operations, to do a better job of service delivery, to generate benefits to society. But we need to look at that as a return, not as a no good deed goes unpunished kind of dynamic. And so some of that is a better engagement through stakeholders. Some of it within agencies, though. I mean, you mentioned IT as the great engineering apparatus that exists in organizations where there's perhaps an opportunity here to collaborate a little bit more tightly with businesses to the extent that they are not. In some agencies, IT is going to run off and choose the standards, choose the architecture, choose et cetera. I think a better, stronger business IT interface is probably a good way to address that, because businesses know a little bit more typically about the problems that they're facing. And so getting that interaction matured is in some cases going to be needed as well.
Yeah, I think you've raised a very legitimate question, but I do want to highlight some of the areas where government has made some significant strides. First, the Office of Management and Budget has encouraged every federal agency to hire and assign a chief data officer, whose primary job, whose primary mission is to drive this discussion around how to get from raw data and knowledge to insight for the benefit of the agency mission. So now we don't have it spread across IT, it's now focused in a particular person's job. Additionally, we have two really great documents that are driving the agenda for that person. The first is the Big Data R&D Strategic Plan that was released October 2016, and then the Artificial Intelligence Federal Strategic Plan, which was released in November of 2016. These two documents guide the strategic activities for individual agencies that the CDO can now use to drive some of the main issues that are holding us back from, catapulting into this new age, and that would provide what I think you're referring to as a sustainable model for moving things from lab through across individual agencies through across multiple agencies. And so the Federal Data Cabinet, which is the forum that these chief data officers participate in, is not unaware of that issue and really focused on it, because we have engaged them at Intel several times and continue to work with them to help accelerate some of their issues around sustainability. So great question. We have time for one more question. Yes, sir.
Morning.
Do we have a mic? Oh, I'm sorry. We had another one already keyed up. Do you mind? Would it be okay? Okay, thank you.
Yes, my name is Daryl Grant. I'm with the Health and Human Services. Actually, this is for Michelle regarding, you were talking about proof of concept in the acquisitions process. Where are you taking that? What are the next steps for that at GSA?
Well, our next steps are to try to get funding to implement the proof of concept. So that is our next step. So we're right now trying to secure funding to replace. We have some very old technology and databases that the Schedules program currently utilizes. So if we are successful, we hope to utilize this technology to wean ourselves from older technology.
Okay, thank you. And so we have time for your question. Thank you.
All right, great. Good morning. This is for Jeff Allstott.
Can you tell us who you are and where you
Yes, Dan Kowalczyk from Inobros Federal. With the fragility and the robustness of some of these AI systems, and you mentioned what DARPA is doing with the assured autonomy.
No, DARPA's doing assured autonomy.
yes.
Sorry
Yeah.
about that.
How do you see this developing in the future, and what are they doing to actually make a system more robust so that it's not just telling you, hey, Jeff, I found your stapler, it's over on Milton's desk, but also, you know, there's a patch due in your Java, and I actually updated the patch, and here's the date I did it on, and this is when the next one will come out, and then something else that this has to do with your infrastructure. And it's kind of a, you know, I can see where some agencies are going to want to know, well, how far can I stretch this AI system? And it's not just a single use case like may discuss with the chip versus the GPU. It's a multi-use kind of cross-functional AI system that doesn't just do one thing with that specific set of training data.
Right. So it's important to understand that the reason we're even talking about AI today, why it's in the air and the media and whatnot in the past year or three, is because the current systems are far more robust than they ever had been. So, for example, the first time that an autonomous car drove across the country, anyone want to guess when that was? 1995. It was the first time that an autonomous car drove from Washington, D.C. to L.A. But the question is, how autonomous was it, right? What portion of the miles was someone's hand not on the wheel? And how many different routes could it have taken? So in this particular case, they pre-planned the route, they pre-planned which stops they were going to take, right? So this was a system that operated that was fragile. But the reason that we're talking about autonomous cars today is because they are far more robust, able to handle far more use cases, weather cases, new roads and whatnot than they ever had been. The issue is that we can get to something that really looks human the vast majority of the time, but once in a great while, by accident or by nefarious means, it fails. And then if you have already given all of this autonomy and agency to your machine learning system, now you have a problem, right? This is not wildly different from any other previous automated system. Cyber everything sort of fits this bill, right? So this is not new problems, right? It's just that we now have examples that lead people that aren't savvy about the particular technical details to sort of round up and say, okay, it's perfect. It's just as good as a human would be in this case. But in fact, they're not. So trying to get those last little bits of fragility out is, again, really active research. So it's a thing that I know various parts of government research are looking at in depth. Even parts of the private sector out in Silicon Valley are looking at it. But you know, different users have different concerns or use cases. So, but it's unfortunate that I can't say, oh yes, here is the solution to you about how to ensure that you have a robust system, and that, oh yeah, here's the plan to roll it out. Because we're not quite all the way there that we can say that yet. We hope to within a small number of years, but it doesn't mean that you can't use things now, right? Autonomous cars are much more useful than they ever had been within a certain set of driving conditions. Just want to make sure that users are aware of what they can and cannot do, and where they will be robust, and where they have the possibility of being fragile, and just plan for that that small possibility.
There are so many more things we could talk about: neuromorphic computing, quantum, a whole series of new use cases. But let's thank our panel and appreciate all of the conversation we've had in helping us to understand where government sees AI. So I'd like to invite Justin to come on back up.
All right, thank you so much. And I actually think I'm mic'd up now, so I don't have to go to the podium. Thank you so much to that panel. It's fantastic. And one of the things that our good friend at IARPA alluded to is there is more going on this space than people know or appreciate. It's throughout the federal government, coming from so many different angles, so many possible use cases. And while I give my little speech here, if the people who are going to be part of this next session could please come up to the front and take your seat at some chairs, and I'll kill some time until you're in there. As part of what we have is, it's called the National Science Technology Council Subcommittee for Machine Learning and AI.